Okay, so in this video I am going to explain the another types of the problem, that is minimization types of problem of linear programming problem. So here in the last videos I have taken examples of the maximization types of the problem. Now I am going to take the minimization types of the problem by using graphical method. So now I am going to apply the graphical method to solve this LPP. So this is very simple, same approach have to apply, and at the end of the solutions we will see how to find the feasible solution and how to see is there any optimal solutions or not, or is there some numbers of basic feasible solutions, or how many numbers of feasible solutions. So whatever the things we will see, and how to find the solution, that is the main aim to apply the procedure. So now I am going to start. So here objective functions already have given minimum z. So question is of the minimization types of the question, 3x1 plus 2x2, this is the objective functions. And the constraint, there are 3 constraints have been given. In the previous questions for the maximization problem I have taken the examples of 2 constraints. Here I am going to take the examples of 3 constraints. So in these 3 constraints, first our steps is to change these inequalities into the equation form. So once we will change these inequalities into the equation form, then we will find the values of x1, x2, and then we will put these values on the xy axis, and we will draw the graphs, and we will see what are the different corner points, and we will find the solution. So same procedure, same steps I am going to apply. So first you need to change this inequality into the equation form. So 5x1 plus x2 is equal to 10, 2x1 plus 2x2 is equal to 12, x1 plus 4x2 is equal to 12. These 3 inequalities have been changed into the form of equation. So now here same procedure we need to apply. We need to draw this table for all these 3 equations like this. All these 3 equations we need to draw this table and need to write the values of x1 and x2, x1, x2, x1, x2. Same procedure, whatever I have applied in the maximization type, same have to apply into the minimization types of the problem. So now one by one, suppose you have given this table as a 1, this equation, second equation, this equation named equation third. According to this equation, just we are going to prepare the table, and based on this table we will draw the xy, we will draw the straight line over the xy axis. So xy axis is here going to be considered as the x1 and x2. Okay. Now if you put this 0 into the first equation, so this x1 value will be 0, so this term will be 0. So now x2 value will be 10. Similarly, if you put the values of x2 0, then this term will be 0, x1 will be 2. Same you have to put all these values into all these 3 table for their respective equations. So where x1 will be 0, this term will be 0, x2 will be 6. When x2 will be 0, this term will be 0, x1 will be 6. Similarly, when x1 0, x2 will be 12 by 4, 3. When x2 0, this term x1 will be 12. So now we have got all these values x1 and x2. Now the next steps to draw the graph. Here these graphs on x and y. So here we are going to consider as x1 and x2. So now we are having x1 and x2. This is the origin, 0 and 0, and we are going to take some equal division, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just have divided this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have taken 12 division, and we have taken 1, 2, 3 in this respect. We can take in 2, 4, 6, 8 in this division also. So we have taken 1, 2, 3 just for the clarity, because it is not a graph paper. So we are going to draw over the board. So here we will get the rough results. So in these results, just we are trying to get as maximum as possible clarity. So now when x1 0, x2 10, x1 0, x2 10. So now we can find here 0 and 10. When x1 2, x2 0, so 2 and 0. So we can draw this graph, just need to join these points and need to draw this graph. So now this is the straight line graph. Now when x1 0, x2 6, so 0 6. 6 0, you can draw here. So 0 6 and 6 0 will give the result like this. This is the straight line. 0 3, 0 3 are going to give here, and 12 0, 12 0 are going to give here the point. So just draw 0 3 and 12 0. This is the straight line. So now which point is going to be considered as a corner point? So because here in this just come to the constants. So in these constants, 5x1 plus x2 greater than equal to 10. So 5x1 plus x2 greater than equal to 10, this is the first table, and 5x1 greater than equal to 10, 0 10. So this is the first equation from the first straight line from the first equation. 0 6 6 0, this is the second straight line from the second equation. 0 3, this is the third straight line from the third equation. Okay, now we have drawn the graph by the help of given equation. Okay, now next, see here it is, now here it is very important. Here you just need to find the common region, that is called feasible region. So for 5x1 plus x2 greater than 10, now we can draw a line like this. 5x1 plus x2 greater than 10. This is the line. Because it is showing greater than, so now we can draw graph like this. Similarly, for second, 2x1 plus 2x2 greater than equal to 12. So 2x1 plus 2x2 greater than equal to 12, second equation. You can draw this second equation in this form. Okay. Next, third equation is going to show x1 plus 4x2 greater than equal to 12. So third equation, this one. No, it is showing this one. Out of all these three, where we are going to get all these three different colors, all these three colors, combination of all these three colors. So combination of all these three colors we may find here. It is very clear. If you are going to see the intersection, because it is greater than equal to, so we need to find at the upper portions of xy axis. So now see here. Here in these two lines, intersection of 1 and 2, first straight line and second straight line. This is green, this is blue. These two are separate. But here green and blue are going to give the mix. So these two are the intersected portions of these two straight line. Similarly, if you come here, here it is only red. So just delete single color. Here red and blue, just delete this color. So now we have deleted here only green, just delete this color. So which color now is going to show? Here we are going to get all these three colors, red, green and blue. Just I have introduced different colors just to for the easy and for the understanding point of view. But the concept here, at all the times we need to find the intersected point. So this is the intersected point from the second equation. This is the intersected point. So now we are having these two intersected point here, and on the axis of x2 this is the intersection point. This is the intersection point over the x1 axis. This one is the intersection point over the x2 axis. So there are four corner points, 1 2 3 4, and when you find the intersected point, just you need to select the upper part. So this is the main method. Just you need to select the upper portion of the graph. So now we have selected these four intersected points, and just you give the name. Like suppose this one you can give the name A, here can give the name B, here can give the name C, here can give the name D. Okay, for A 12 and 0, for A 12 and 0, for B we don't know exact, for C also we don't know, for D 0 and 10. So here if you are going to see these points, these corner points on the graph paper, then easily you can find, because just you need to put the perpendicular line over this x1 axis. Similarly, you put the perpendicular line over the x2 axis. For this corner points also you can put the straight line, here also a straight line, that is the perpendicular line. Then you can find the values by seeing the graph paper. But because we are not having the graph paper here, so we need to go for the solution, and that is very easy way to find the solution for this corner point. We need to go for the respective equations. So which equations now we are going to consider? First, see, 1 a straight line, 2 a straight line, this one is the second straight line, this one is the first straight line. So first and 2, this is showing the first and second equation. So just take these first and second equations, so we will get the values of corner point C. So first and second equation can take here 5x1 plus x2 is equal to 10, 2x1 plus 2x2 is equal to 12. To solve this, because here it is 2, we need to cancel this one, so we need to multiply this one with 2 with this one with 1. So 5 into 2, 10x1 plus 2x2 is equal to 20. Similarly, 2x1 plus 2x2 is equal to 12. Now these two are equal, so we can subtract and this one will be cancelled. So 10 minus 2, 8x1 is equal to 20 minus 12, 8. So x1 value will be 8 by 8, 1. So now you can write here at the C point, C corner point, 1 value, first value is a 1. For the second, just you need to put this x1 in any of the equation. So I am going to put this x1 in the equation 1. So this one, x1 1, so 5 into 1, 1, 10 minus 5, 5. So you can write here 10 minus 5 is equal to 5. Simple. X1 value just I am going to put 1. So 5 into 1 is equal to 5. X2 is equal to 10 minus 5, 5. So now we are having this corner point 1 and 5. Similarly, to find the corner point B, we need to consider which equation we need to consider. It is very simple. Which equations is going to intersect? This one is the third equation. This one is the second one. So we need to take second and third equation to solve. So 2x1 plus 2x2 is equal to 12. x1 plus 4x2 is equal to 12. So very simple, just we need to make this, because here it is showing 2, here 4. So we need to make this one as a 4, this one will be same. So 2 into 2, 4x1 plus 4x2 is equal to 12 into 2, 24. And here it is 1, so same, x1 plus 4x2 is equal to 12. So just take a negative sign, this one will be cancelled, and 4 minus 1, 3x1 is equal to 24 minus 12, 12. So x1 value 12 by 3, that is 4. So you need to, first x1 value is 4, so you need to write here 4. Put this 4 into any either of these two equations. So suppose I am going to put these values into the second equation. So x1 value will be 4, 12 minus 4, 8, 8 by 4, 2. So x2 value will be 2. So now it is going to intersect at a point 4 and 2. In roughly also we can see at the x1 axis, now it is going to give the perpendicular line at the point 4, and now here it is 2, so 4 and 2. Here if you try to come to see 1 and 5, just near about, because it is not exact graph paper, so we can find the near values only. Now here, now we need to check a 12 and 0. So a 12 and 0 I have given, so the same value we need to put into the objective function, and we can see, so z at A, z at B, z at C, and z at D. Now we are going to check which one is going to what result. So if you are going to put 12 and 0 into this 3x1 plus 2x2, so what's the value? 3 into 12 plus 0 into 2. 3 into 12, 36. 0 into 2, 0. 36 plus 0, 36. Same for this one, B. B is a 4 and 2. So x1 value will be 4, 3 into 4, 3 into 4 plus 2 into 2. 3 into 4, 12 plus 2 into 4, 2 into 2, 4, 12 plus 4, 16. Same procedure need to apply. Here ZC at C, now we are having 1 and 5. So x1 value will be 1, x2 value will be 5. So x1 1, 3 into 1, 1 plus 2 into 5, so 3 plus 10, 13. So you need to write here 13. Same you need to apply for the point D, 0 and 10. So 3 into 0, 0 plus 2 into 10, 20. 20 plus 0, 20. Now we have got all these values. Now we are having all these values in our hand. Z at A, Z at B, Z at C, Z at D. So what the question is going to ask? Question is very simple. It's going to ask the minimum Z. It means we need to minimize the cost of the product. It means from the some text questions have changed into the mathematical form, and finally we need to put all these values of x1 and x2 into the objective function and check which values are going to give the minimum result. So out of these 36, 16, 13 and 20, 13 is the least value out of these 4 values. It means this is the solutions of our problem. So just you take Z minimum at which point? C 1 and 5 is equal to 13. So Z is equal to 13, x1 is equal to 1, x2 is equal to 5. So this is our solution, x1 1, x2 5, Z 13. So this is the simple procedure to solve the two variable equation, two variables given, minimization types of the questions, and already have introduced maximization types of the questions in first videos. This is the second videos. Next I will take the examples of simplex method, and I will try to give you the best solution, best way to solve the problem, that is the simplest way to solve the problem. And in next videos we'll see the maximization types of the problem of linear maximization types of the problems of LPP. Okay, thank you.